Oh, something did fall off. Oh, very good.
Oh my goodness, bye-bye.
No grapes again?
Okay, cool. Thank you. Right. Okay, great.
Boy,
Give you one more thing.
a real life example.
I need better rock pen.
We have so many.
But no, real life. I can see this one now, though.
Alrighty. I have two circuits here, a series circuit and a parallel circuit. Here's what the series circuit looks like. Okay, you've got your 120 volt source, and then you've got your 3 light bulbs hooked up in series with each other. Okay, and each of these light bulbs is a 60-watt light bulb. All right. I've also got a parallel circuit, a circuit that's hooked up like this. Here's your 120 volt AC source, and I've got one 60-watt light bulb, a second 60-watt light bulb, and a third 60-watt light bulb, all hooked up in parallel with each other. Okay, we're going to go through this sheet and answer every question. Now, on my exam, I will ask like 2 of these or 3 of these questions and expect complete answers. I don't expect like a one-word answer. That's not going to get it done. So when you answer these questions, make sure you write complete answers. Also, on last year's AP exam, one of the free response questions was essentially similar to this. And so that's one of the reasons why my kids did so well, because I didn't know that was going to be on there, but I suspected it would, and so I'd do the big light bulb demo, and sure enough, it paid off. So here we go. Number 1, what is the voltage drop across each one of these parallel bulbs? I'll give you a choice. We're going to vote in a second. What's the voltage drop across each one of these 3 bulbs? Here's your choices: 120 volts or not 120 volts. You guys ready to vote? How many people say the voltage drop across each one of these 3 bulbs is 120 volts? Okay. How many people say it's not 120 volts? Okay. Someone who voted for 120 volts. Why? Why 120 volts? What would you say is your answer? Oh, please. Why is each one of these guys 120 volt drop? Here, I'll even, maybe if I draw it in, it'll make you feel better about answering. Here, 120 volts, 120 volts, 120 volts. Why would you say each of those is 120 volts? Tell me. Yes, Noel. Thank you, Noel. Thank you for saving me.
Because out of the positive side of the battery comes 120 volts, and back into the negative side of the battery goes in 0 volts. So in order for that to happen, you have to lose 120 plus all of them.
Okay, beautiful. That's a really, really good answer. There's an easier answer because they're all hooked up in parallel, right? And that would be good enough on an AP exam because the definition of parallel wiring is they all have the same voltage. So you'd say, hey, all 3 volt bulbs are hooked up in parallel. And by definition, parallel wiring means they have the same voltage. But if you want to give Noel's answer, that's fine too. Hey, this guy, one side is hooked up to the positive terminal, the positive terminal of the battery, and the other side is hooked up to the negative terminal of the battery. Positive 120 and 0. Okay. But let's look at the series circuit. What's the voltage drop across each one of these resistors in the series circuit? I'll give you a hint, or I'll give you a choice. It's either 120 or not 120. You guys ready to vote? How many people say the voltage drop across each one of these bulbs is also 120 volts? How many people say it's not 120? Okay, yay for you guys. So now specifically, how many volts is it? Yes, Fatima? You say 40. How many people agree with her that it's 40? Hey, yay for each and every one of you guys. It sure is 40. Okay. So now the question is why? Why is it 40 for each one of them? It's Fatima.
Because the same current is going through each of the bolts, and each of the bolts have the same distance, or the same power.
We've got voltage drop, let's say. V equals IR. Beautiful. So all three bulbs have to have the same voltage drop. And what do those voltage drops all have to add up to? Yeah, so that would be a good answer. Each bulb gets the same current, so they all have the same resistance, so they all got the same voltage drop, and those three voltage drops have to add up to 120. That is your charge. Here, just a second. I'm gonna close those windows. Although it's so nice and fresh to have those windows open. I'm gonna keep them open. Okay. So your charge right here, each coulomb of charge has the capability of doing 120 joules of work. It passes through this bulb and gives up some of its energy. Then it passes through this bulb, gives up some of its energy, passes through this bulb and gives up the rest of its energy. And now when it reaches here, it's at 0 volts, right? So you're going to have to give up 120 joules per coulomb of electric potential. That is, you'll have to give up 120 joules of energy for every coulomb that goes through here. And again, because of what Fatima said, same current, same resistance, it's got to be the same voltage. So it's going to be 40, 40, 40, so that the sum ends up being 120. Okay, great. Hey, let's turn these suckers on. Here we go. Someone tell me, which are the parallel bulbs and which are the series bulbs? Which is which? Can I tell just by looking at, by just looking at them? Yes, Imani.
The parallel bolts are the brighter ones?
Imani says the parallel bulbs are the brighter ones. How many people agree with her? Beautiful. How did you know?
Because there's more voltage going through it. It's 120 compared to 40.
Thank you. Because they got more voltage. Each bulb has a greater voltage difference. Each bulb is receiving more joules of energy. You guys okay with that? So yeah, these guys have to be brighter. So when they say, why are the series bulbs dimmer than the parallel bulbs? It's because each bulb has only 1/3 the voltage. 40 volts versus 120 volts. Same resistance, 1/3 the voltage. Here's my next question. This isn't on the sheet, but here's my next question. In light of the fact that power equals V squared over R, how many times more power are these bulbs dissipating than these bulbs? How many times more power?
9 times.
Each of these bulbs is getting 3 times the voltage, right? How many people say, since each of these guys get 3 times the voltage, they're dissipating 3 times the power? Oh, I couldn't fake anyone out. What's the actual answer?
9 times.
Chris, what?
9 times.
Why 9?
Because it's V squared.
Thank you. You guys okay that these guys are dissipating 9 times the power of these guys? Yeah, the voltage is 3 times, but the voltage is squared. Okay? Great. What was I going to say? Now, are these guys 9 times brighter? Well, no, we don't really know that because it depends how much of its power is in the infrared region. These guys are certainly a lot hotter than these guys. These guys I can touch and not get burned. This one I can't touch without it hurting a little bit, which means there's a lot of the energy being dissipated in the infrared range, which doesn't contribute to its brightness, But definitely 9 times the power. Okay, great. Number 4. What happens to the other 2 bulbs when I remove one bulb in the parallel circuit? I'm going to remove one bulb. I'm going to remove this bulb from the parallel circuit. What happens to the other 2 bulbs? I'll give you several choices. The other 2 bulbs, do they get dimmer? Do they get brighter? Oops. Do they get dimmer? Do they get brighter? Is the left bulb going to be on, but the right bulb turns off? You know, left bulb on, right bulb off? Or is there no change? No change in the other two bulbs. Please think about that for a second, then we'll have a vote. Okay, here we go. How many people say the other two bulbs get dimmer? How many people say the other two bulbs get brighter? Okay, one of you. How many people? Two of you. How many people say the left one stays on, but the right one turns off? Okay, several of you. And how many people say no change? Okay, well, let's see which it is. What happened?
No change.
No change, right? Do you see that? No change. So now, in light of the fact that the answer is no change, someone explain to the class why. Why no change? Yeah, Gavin.
Well, even though you're taking one of the bulbs out of the parallel series,
Parallel circuit.
parallel circuit, you're not changing the resistance, the current, or the voltage flowing through them, so their brightness wouldn't change.
Thank you. I'm just going to repeat what you said. Even though you're removing this guy from the parallel circuit, you're not changing the resistance, the current, or the voltage through that bulb. Nothing's changing for this guy. He's still got a 120 volt drop across him. He doesn't care what this guy does. You see that? Here comes my next question. I'm now going to remove the center resistor, the center bulb, from the series circuit and leave it as an open circuit. I'm going to remove the center bulb and leave it as an open circuit. The circuit's going to look just like that. Tell me, the other two bulbs, do they get dimmer? Do they get brighter? Does the top bulb stay on, but the bottom bulb turns off? Or instead of no change, how about if I just say they both turn off? Okay. Which do you think it is? Do the other two bulbs get dimmer, brighter, top on, bottom off, or both off? Are you ready to vote? Okay. How many people say, oh yeah, did we start the camera? Oh, good for you. I don't remember waving. I forgot
You
to
didn't
wave.
wave.
Oh my gosh. How many people here say it's dimmer? The other two bulbs are dimmer. No dim bulbs in this class. How many people say it's brighter? Okay, the other two bulbs brighter. Okay, great. How many people say the top one is on but the bottom one is off? Because there is an open circuit after all. Okay, great. And then finally, how many people say they both turn off? Okay, several of you. Alrighty, let's go for it. Ready? 1, 2, 3. Both turn off. Both on, both off. So someone explain to the class, why is it that removing this bulb turned them all off? Go ahead, Justin. Wait, I'm sorry, Anais. We never get to hear from you. Go ahead, Anais.
Well, I actually feel that Justin never gets to say.
Well, he doesn't either, but he's a quarterback and stuff.
Okay. I was thinking because you broke the circuit, it's no longer fully flowing through.
Beautiful. Is that what you're going to say, Justin?
No, it wasn't.
Sort of.
What were you going to say?
It's an open circuit, so no voltage can go through it.
Yeah, beautiful. Both of you are correct. And we say no voltage, I'm going to assume you meant no current.
Yeah.
Gets through. Yeah, both of what you said, both of you is awesome. You guys okay with that? In order for a bulb to stay on, I need charge to enter the bulb, give up energy, and then move along to let the next bunch of charge enter it, give up its energy, and move along. You see? But by making this open circuit, I make it so that no current can get past this point. And just like a traffic jam or damming a river, once no current can get past here, no current is going to flow at all. And without a flow of current, you're not going to be able to get any power from that electricity. Because you need current to flow. You need a circuit for current to flow. Yeah, beautiful. Good job, you guys. Okay, it is now time to talk about number 6. So you tell me, series or parallel, what kind of wiring do we have in our homes?
Parallel.
How many people say parallel? Yeah, so please explain, why parallel, why not series? Yes, Sean?
Because when you turn one light off, it doesn't like turn all the other lights.
Exactly. I don't want to turn my TV off and have the refrigerator turn off, you know? Yeah, exactly. Yeah, we need everybody to be independent of each other. Yeah, good. Okay, so number 7, draw how a fuse should be attached so that your home appliances are protected. Let me show you what I'm talking about. Let me put this guy back in here. Okay, this is my 60-watt bulb. Okay. If these devices pull too much current, then I get too much current flowing through the wires which are inside your walls. And if those wires get too hot, then you start a fire inside your walls. And that's really bad because home fires kill, you know? So you need to make sure that if you start pulling too much current, that you have a fuse that turns everything off. You want this one device to create an open circuit that turns everything off. Well, if you want to have a fuse that by him and him alone creating an open circuit turns everything off, do you want that fuse in parallel or in series with everything else? Yeah, series, because series is what turns everybody off, right? Parallel is not going to turn everybody off. Series. So where should I put my fuse?
And
Yeah, go ahead.
I was gonna say maybe like right at the start of it, so that way it gets with everything.
Hey, absolutely. Right at the start, put your fuse right there. That's your fuse. So that if you pull too much current and the fuse has to create an open circuit, okay, then it deprives everybody of current. You want everything to turn off if your fuse breaks. And that's what it's called. In fact, they even call them breaker switches now. Because a fuse used to be a thin strip of wire that if it pulled too much current through the wire burned out, and then you'd create an open circuit that way. But now fuses are magnetic. They're like relays, so that when you pull too much current, it clicks, magnetically, and now you have to walk over and turn it off and turn it back on, and then you've reset your fuse. Yeah, that's it. That's your fuse. Okay, hey, let's do some math. Look at number 8. The voltage is 120 volt. Oh, by the way, 60 watts, okay? When the manufacturer says a bulb is a 60-watt bulb, they're assuming that it's being hooked up in parallel. They're assuming 120 voltage drop across that 60-watt bulb. So please do part A. The voltage is 120 volts and the bulbs are 60 watts. Please find me the resistance of a bulb. Please do that now. What's the resistance of one bulb? Of one 60-watt bulb? tell me, what equation should I use to find the resistance of a bulb? Go ahead, Chris.
P equals B squared over I.
Yeah, great. I got a 60-watt bulb. I got 120 volts. I got an R. So what'd you guys get as the resistance? Yeah, good, 240. So each of these bulbs is 240 ohms, okay? Just V squared over R. Tell me, when I hook up these bulbs in series, should I be calling these bulbs 60 watts? No way. They only get to be called 60-watt bulbs if you're hooking them up in parallel across the 120-volt source. But if you're going to put only 40 volts across these bulbs, they don't get to be 60-watt bulbs anymore. So I'm just going to erase the 60 watts, because that's just misleading. But I can label them as 240 ohms. You know, yeah. Okay. So tell me, these three 60-watt bulbs, what's the total power dissipated by this circuit? By this parallel circuit of these three 60-watt bulbs, what's the total power? Yeah, is anyone thinking 180? Yeah, that's it, sure. Total power, 180 watts, okay? But now, more interestingly, I'd like everyone now please figure out what's the total power dissipated by this circuit. What's the total power dissipated by the series circuit?
How?
There are many ways to do this, and they're all correct. Okay, what'd you guys get? Time's up. How many watts? Say that, Chris?
20 watts.
Chris says 20 watts. How many people agree with him? Yay. Yay for you guys. Logan, how did you do it?
I just did B squared over R and added up all of the watts and just divided resistance, and then divided the 120 squared by 720.
Beautiful. How many people did it Logan's way? Yeah, that's great. Did anyone do it a different way? How'd you do it, Noel?
Okay, so I used the same formula,
Okay.
but I did 40 squared because that's the voltage dropped across each,
Uh-huh.
over 240 for the resistance, and multiplied by 3 because there's 3 volts.
Good. Here, just a second. I'm not going to do decimals. Yeah, so she got each individual bulb dissipate 6 2/3 watts, multiply by 3, you get your 20 watts. Excellent. Okay, did anyone do this by involving current? Did anyone involve current? So no current fans, huh? Because another way to do it would be to go, hey, power equals IV. And because I've got 720 ohms and 120 volts, that's 1/6 of an amp. This power supply is going to deliver 1/6 of an amp, and it's a 120 volt power supply, and you get your 20 watts that way. Let me ask you another question though. Do you remember early on when I asked you how many times brighter this guy is than that guy? Or how many times more power? Do you remember what that number was?
9.
9 times. So this is 180. What's that going to have to be? Yeah, 1/9 of 180 or 20. Did anyone just do it that way? Because that way would have worked as well. Just say, hey, it's 1/9 the power, 20. Boom. Okay. Here's the last thing we're gonna do. Let's go to our 200 watt bulb. This is a 200 watt bulb. $200 in the parallel circuit. I'm going to turn it on. Let me see if you can tell that it's actually 200 watts. Does that look brighter to you guys?
Just a little.
Yeah, a heck of a lot brighter. You guys okay with that? So here's my question. Why is it that a 200 watt bulb has a lower resistance than a 60 watt bulb? Yes, Logan?
Because for P to go up, R has to go down.
Beautiful. You guys okay with that? If you got P equals V squared over R, and the V is 120 volts for all of those bulbs, absolutely. If I'm going to have bigger power, I need less resistance. In fact, I need like about a third the resistance, right? A third the resistance. Let me ask you guys another question. Oh, wait till you write that down. Yeah, power, I couldn't say any better than what Logan said. P equals V squared over R. Bigger P, you need lower R, because the V is the same. Suppose, now these incandescent bulbs, all they are is just a wire. You put current through the wire and the wire gets so hot that it glows white and then it lights up your room. That's all these incandescent bulbs are, just a wire that glows hot. Let's say my 60 watt bulb has a filament that looks like this. It's either my brother or a telemarketer. Telemarketer. The 200 watt bulb is going to have a different looking filament. Let me ask you guys, is the 200 watt bulb filament going to look like this, a lot fatter, or is it going to look like this, a lot thinner? Which of those two filaments is the 200 watt bulb filament if this is the 60 watt bulb filament? Please think about it for a second, then we'll vote.
You should know the formula.
Okay, you guys ready to vote? How many people say the 200 watt bulb filament must be fatter? Okay, how many people say thinner? Alrighty, well, I'll tell you what, the answer is fatter. Someone tell me why. Why would the 200 watt bulb filament have to be fatter? Yes, Fatima. Oh, wait. Yes, Justin.
Does that have to do with the formula that involves rho?
Yes, it does. You mean the formula resistance equals rho times L over A?
Yeah.
Please tell me more.
If the wire's fatter, it has a larger cross-sectional area, which means the resistance would be smaller.
Thank you. You guys okay with that? My 200 watt bulb has a smaller resistance. In order to get a smaller resistance, it needs a bigger cross-sectional area. Yeah, and that's the reality of it. I'm looking at it right now, and it's obvious to me that the filament of the 200 watt bulb is a lot fatter than the filament of the 60 watt bulb. Yeah. Okay, I think there's one more thing we have to do involving 200 watt bulb. Oh, no, two more things. How does the 200 watt bulb look when it is put in the series circuit? Okay. I'm going to put this 200 watt bulb into the series circuit. Okay. Now, let me just go to this circuit and replace this. This is no longer a 240 ohm resistor. It's approximately an 80 ohm resistor, approximately 1/3, because it's got approximately 3 times the power. So it's 1/3 the resistance. My question to you is this. Number one, he's obviously going to be dimmer because he doesn't get the full 120 volts. My question is he going to be dimmer or brighter than the other two bulbs? is my 200-watt bulb, and of course I put that in parentheses, in quotes now, because this is no longer a 200-watt bulb because it's not being attached to 120 volts, but is the 200-watt bulb going to be brighter than the other two? Or is it going to be dimmer than the other two bulbs? Which is it? Please think about this for a second. It can't be the same because it's not the same resistance. Okay, you ready to vote? Okay. How many people here say that the 200-watt bulb is going to be brighter than the other two? Okay, a couple of you. How many people say it's going to be dimmer than the other two? Okay, how many people have no opinion? Yeah. Well, hey, let's find out. You ready? 1, 2. Well, Sean, why did you say brighter?
Because it requires more power to light up, so I just thought like it's not as much as the other ones, so it'll be brighter.
Okay. Someone who chose dimmer. Why dimmer? Yeah, Anais.
That makes
That's
sense,
80
but
ohms.
because like it requires more, there's not enough to like fully make it bright.
Okay, you're thinking because it requires more, there's not enough. Okay. Noel, what do you say?
Because I use the formula P equals I squared R.
Yes.
And you're gonna have the same I going through, and the smaller R is gonna make your power smaller.
Okay. Do you hear what Noel said? She said she used the formula power equals I squared R, and they all get the same current, but now that he has less resistance, he's going to dissipate less power, which means he will not be as bright. How many people have been convinced by Noel's logic? You're all un-American. I'm sorry. You're bad, bad Americans. Here it comes. You ready? Dimmer. In fact, I mean, it's dissipating so little power, it's not even lit. Whoa. Okay? You guys okay with that? So it is dimmer. So please talk about why. And the reason why is exactly what Noel said. Power equals I squared R. They all got the same current, but that guy's got a lot less resistance, so he's going to be dissipating less power. I squared R. Great. What? I squared R, same I, lower R, less power, less P. But here's one last question. Do you notice what had happened to the other two bulbs? Did they go brighter or dimmer? Like, look at them now, and then I'm going to put this guy in. Okay. Do you see that? You see that they're dimmer with the 60-watt bulb, the 240 ohm bulb? They're dimmer than when I put this 80 ohm bulb in. Now they're brighter. Can someone explain why is that? Why do the other two bulbs get brighter when I put the 200-watt bulb in there? 200-watt bulb. Yeah, Alejandro.
Because when you put in the 200-watt bulb, the equivalent resistance is less, so the overall current is greater. So then they have and then since the current is greater, the power will be greater.
Yeah, that's it, pure and simple. I'm going to repeat what you said, I hope you don't mind. By replacing a 240 ohm bulb with an 80 ohm bulb, I've reduced the equivalent resistance, which means I increased the current through every single bulb, and now this bulb is getting more current than it got before. And his power is I squared R, same resistance, more current, brighter. Absolutely, that's the reason. Good job, Alejandro. That would be like on an AP exam, that would get you full credit. I mean, yeah.
Can you stick your head in this shot real quick? Focus.
Stick my fat head in there. Sometimes I have to do the, zoom in, zoom out.
Ah, there we go.
Okay. And I think, hey guys, we're done. We're gonna complete this demo tomorrow. So for now, we say bye.